Hello everyone, so this is more of an application problem. We see that we have a cup. This cup is probably made of something like paper because it has no width whatsoever. Anyways, this cup is of a cylindrical shape, and the radius of its bottom is r, and the height of this cup is h. Now we want to find the minimum value of pi r squared times 2 times pi times r times h, such that the value of this cup is basically 1,000. So we have these two formulas. One is the volume of this cup, which is pi r squared times h, and this is equivalent to 1,000. Now we want to find the minimum value of pi times r squared plus 2 times pi times r times h. Well, we want to minimize the surface of this cup. Well, in these two formulas, we can see that we have two variables. One is r, the radius of the bottom side, and one is h. H is the height of this cup. And we want to see how these two variables are related. So let's take a look at the second formula. This is pi times r squared times h is equivalent to 1,000. Now we can see that h is equivalent to 1,000 divided by pi times r squared. So there we have it. This is a relationship between r and h. So h equals to 1,000 divided by pi times r squared. So let's substitute that into the first equation, which is, well, the surface of this cup. Pi times r squared plus 2 times pi times r times h. So h equals to 1,000 divided by pi times r squared. So the first formula can be written as pi times r squared plus 2,000 divided by r. How about let's just call this formula as f of r, as a function of r. So in that case, we can find out the minimum value of this f of r. Now, how do we find out the minimum value of this f of r? We simply differentiate this f of r with respect to r. We want to find an r such that f prime of r is equivalent to 0. So what is the expression for f prime of r? It's quite simple. It's just 2 times pi times r minus 2,000 divided by r squared. And we want to find an r such that this equation evaluates to 0. We can multiply all this equation with r squared. So we can see that 2 times pi times r to the third is equivalent to 2,000. So pi times r to the third is equivalent to 1,000. So we can see that r is basically just 10 divided by the third root of pi. So we can see that when r equals to 10 over the third root of pi, there definitely exists an extreme value for f of r. Now we want to see that whether when r equals to 10 over the third root of pi, if f of this 10 over the third root of pi is actually a local maximum or it's just a local minimum. So let's take a look. For r that is smaller than this value, this 10 over the third root of pi, let's just let r equal to 1. So the value of f prime of r when r equals to 1 is 2 times pi minus 2,000. This is definitely smaller than 0. So we can see that for r that is smaller than 10 over the third root of pi, f prime of r is negative, so it's decreasing. The value of f of r is decreasing. On the other hand, for r that is larger than 10 over the third root of pi, the value of f prime of r is positive. So that means that f of r is actually increasing for r that is larger than this number. So we can see that when r equals to 10 over the third root of pi, we definitely have a local minimum at this point. So this is the answer of our problem. When r equals to this number, we can have a minimum of the surface area.